Question 1. Based on this question, information that we were given is sample size is 42, sample standard deviation is 1.1, population mean is 5.5, and confidence level is 99%. The question asks what is the confidence interval for the population mean. So we just substitute all the information into the formula, and for the t-value we just calculate the degree of freedom by minus 42 with 1, then we get 41. At the 99% confidence interval, the t-value is 2.701. After we calculate it, we will get that the lower boundary is 5.042 and the upper boundary is 5.958. Question 2. What is the difference between null and alternative hypothesis? Null hypothesis is like a claim that says nothing has changed. We assume it is true until the data prove otherwise. However, the alternative hypothesis is what we believe might be true. If the data strongly disagree with the null hypothesis, then we accept alternative hypothesis. B. What is the difference between one-tail and two-tail test? So basically, one-tail test is testing value is significantly greater than or less than a specific number, while two-tail test is testing for any significant difference, whether it is higher or lower. C. What is mean by a p-value? P-value tells how likely it is to get the value observed result if the null hypothesis is true. If the p-value is higher, the weaker the evidence against the null hypothesis and vice versa. D. Based on the question, the information we are given include the population mean is 6.6, sample size is 7, and significant level is 5%. For sample mean and sample standard deviation, we need to calculate using calculator, and we will get the sample mean is 7.557 and standard deviation is 1.177. Step 1. State the hypothesis. Since the question asks whether there is a statistically significant change in the average weight, this is a two-tail test, so null hypothesis is mu equal to 6.6. Alternative hypothesis is mu is not equal to 6.6. Step 2. State the significant level, which we were given 5%. Step 3. Select the test statistic. We use t-distribution. Step 4. Formulate the decision rule. We find the t-critical value from the t-distribution table with degree of freedom equal to 6. At the 5% significant level for a two-tailed test, the critical value are positive 2.447 and negative 2.447. So we will reject the null hypothesis if calculated t is greater than positive 2.447 or less than negative 2.447. And the last step, we need to calculate, make a decision, and interpret the result. We use the T formula and substitute all the information that we get from the question, and we will get that T value is 2.151. Next, we make the decision by comparing the calculated T value with the critical value. Since 2.151 is less than 2.447, the value fall outside the rejection area. Do not reject the null hypothesis, so we cannot conclude that the mean is not equal to 6.6.
So we continue at question 3. The question asks us to list 5 steps to perform hypothesis testing. So the first step is we state the null and alternate hypothesis. Step 2, we select a level of significance. Step 3, we identify the test statistic. Step 4, we formulate a decision rule. And the last step is we take a sample, arrive at decision. Next is question 3b. The question asks that can we conclude the mean salary are greater for the fast food workers than the restaurant workers. The question also asks what is the p-value. So the first step is we state the null and alternate hypothesis. So the H null is mu1, which is the mean salary for fast food workers, less than or equal to mu2, which is the mean salary for restaurant workers. The H1 is mu1 more than mu2. Next is step 2, we select the level of significance. The 0.10 significance level is stated in the problem. Step 3, we find the appropriate test statistic. Because the population standard deviations are not null but are assumed to be equal, we use the pool t-test. Step 4, we formulate the decision rule. We reject if null is compute t more than critical t. The alpha value, which is a significance level, is 0.10. The degree of freedom is 11. So if we look at the t distribution table, the t critical is 1.363. And if we look at the graph, the region of rejection is on the right side, which is after 1.363. So the last step, which is step 5, we compute the t-value and make decision. First, we need to find the x bar 1. So the formula is the sum of x1 divided by n1, which is 855 divided by 6 equal to 142.5. Next is x bar 2. The formula is the sum of x1 and the sum of x2 divided by n2, which is 912 divided by 7 equal to 130.29. Next, we find the standard deviation one. The formula is square root the sum of x1 minus x bar 1 square divided by n1 minus 1, which is square root 749.5 divided by 6 minus 1, which equal to 12.24. The standard deviation 2, the formula is the sum of x2 minus x bar 2 square divided by n2 minus 1, which is square root 1494.47 divided by 7 minus 1 equal to 15.79. Then we calculate the pool sample standard deviation. The formula is n1 minus 1 times standard deviation 1 square plus n2 minus 1 times standard deviation 2 square divided by n1 plus n2 minus 2. And then we got 6 minus 1 times 12.24 square plus 7 minus 1 times 15.79 square divided by 6 plus 7 minus 2 equal to 204.09. Next, we determine the value of t. The formula is x bar 1 minus x bar 2 equal to square root pool sample standard deviation times 1 per n1 plus 1 per n2. We got 142.5 minus 130.29 divided by square root 204.09 times 1 per 6 plus 1 per 7. And then we got the t, which is 1.53. Since t compute, which is 1.53 more than t critical, which is 1.363, we reject the null hypothesis. At the 0.10 significance level, there is sufficient evidence to conclude that the mean salary for fast food workers is greater than that for restaurant workers. Since t equal to 1.53, which is, if we look at the t distribution table, it is between 1.363 and 1.796. So p-value is between 5% to 10%.
So we will continue to question 4a. The question is, we need to make a decision regarding the hypothesis that the training was effective in improving customer relationship. So we need to do 5 steps, which is a first step, which is we need to state the null and alternative hypothesis. So our null hypothesis is population mean is less than or equal to 0, and our alternative hypothesis is higher than 0. For step 2, we need to state level of significance, which is 0.05 as significance level. For step 3, we use t-test. For step 4, we need to do a decision rule, which is reject null hypothesis if
T is higher than critical T, or if compute T is less than negative critical T. So our significant alpha is 0.05 and our degree of freedom is 6. So based on table, our T critical is 1.943. So our graph will become on the right side, which is the region of rejection in the right side. So for step 5, we need to compute of T value and make a decision. So we will find T value and we will get 2.5.3. So as a conclusion, we can see that 2.5.3 is higher than 1.943. So we will conclude that we reject the null hypothesis of no difference since compute T is greater than a critical T value. So you can see our graph, the point is inside the region of rejection. So that's why we reject the null hypothesis. So we continue to question 2. So we are given an incomplete table. So before we answer the question, we need to complete the table first. So for the DF error, we get 9. For SS error, we get 180. For SS treatment, we get 320. For the MS treatment, we get 160. And for the F, we get 8. So for question A, how many treatments are there? So we need to find the DF treatment, so we will get 3. For question B, what is total sample size? So our total sample size is equal to 12. For question C, what is the critical point of F? So we use the data given, which is 0.05 significance. Our degree of freedom 1 is 2 and our degree of freedom 2 is 9. So we'll get 4.429 as a F critical based on the table. So for question D, write out the null and the alternative hypothesis. So for our null hypothesis, we get the mean is all the same. For the alternative hypothesis, we get that at least mean 1 is not equal to the mean J, which is there's a mean that's not equal. So for question E, write your conclusions regarding the hypothesis. So we get the F is equal to 8 and our critical is 4.426. So we conclude that F is higher than F critical. So it means we reject null hypothesis. So this is significant evidence that at least one treatment is different. So for the last question, we're still in ANOVA topic. So we need to state 6 hypothesis testing. For the step 1, we need to state the null and the alternative hypothesis. So our null hypothesis is all the mean is same, while our alternative hypothesis, the means are not equal. So we will reject the null hypothesis if compute F is higher than critical F. So for the step 2, the level of significance is 0.05. For the step 3, we will use F statistic. For the step 4, we need to state a decision rule. We reject null hypothesis if compute F is higher than critical F and our alpha significance is 0.05 and our degree of freedom 1 is 2 and degree of freedom 2 is 32. So based on the table, we will get the F critical 3.28. So for the step 5, we need to compute the value of F and make a decision. So to compute this, we need to do a ANOVA table. So for the ANOVA table, as you can see, we will get the answer as same in the picture. So for the F, we'll get the 50.51. So we get this answer by divide between mean of square of treatment over mean of square of error. So we get the F. So for this answer, I only used a scientific calculator and to gain this answer. So we can compute that actually we reject the null hypothesis. This is because of our F compute is higher than F critical, which is 50.51 is higher than 3.28. So as you can see, the phi value is 0.00. This is because our F compute is higher than F critical. So for the step 6, we need to state the conclusion. So based on this question, I will conclude that our test at the 0.05 significant level was reject null hypothesis because there is a significant difference in the mean flight time among the Ghost, Jet Jet, and the Coach Airlines. So that's all. Thank you.